Hi, welcome back to the functions, and now we are going to learn about the inverse functions. So what is an inverse function? Suppose we have the function that maps x to the fx is the image of x now under function f. If we want to go the other way from the fx to the x, so this function is called the inverse function. Alright, you learn this in the secondary school. You call it as fungsi songsang. Alright, now you can say that, alright, if you have f of what do we call f of f inverse of x, alright, so this is actually f of f inverse of x. This is actually x, or you inverse f inverse of f, alright, f inverse of fx. This is actually an x, alright, because f inverse, right, that is f inverse of fx, so this is fx, you get the x here, right? That's something like this. What if you have g of fx is the equal to x? So when you have this, you know that g here is actually the inverse function, the inverse of f, right? Because it satisfies this rule, right? Now, right, let's see some examples. What if we have to find the inverse of this one, right? So what you need to do is actually you have to, let y equal to square root of 3x minus 1, and now we have the y square equal to 3x. We want to make x as the subject, so we'll have our y square plus 1 with is equal to 3x. I change the position, I'll have y square plus 1. Now I divide with 3, I have y square plus 1 divided with 3. Alright, but this is actually, alright, now you are letting, okay, now you say this is y. So you let this y equal to fx. Therefore, I want to find the inverse, so I just take the f inverse of y. F inverse of y, I put it this way, so I have to put it this way also, f inverse of fx. So what happened to f inverse of fx? You get f inverse of y. This is actually equal to x. Right, what you are looking for, this is actually the f inverse of y, right? But now I want f inverse of x. So how do I find the f inverse of x? Okay, so this is f inverse of y. That is why it's in term of y. But now you want to have f inverse of x. So you just change the variable y with x. So we have x squared plus 1 divided with 3. So this is the inverse of this function, right? Now, let's go to example 2, right? Hx is equal to this. So we let y equal to hx. So meaning to say that we'll have the h inverse of y will be equal to x. We want to find x now. So we let y, which is equal to 3 minus x over x plus 2. So now I want to make x as the subject. I have to multiply x plus 2 to this left side. So I have 3 minus x. And now I just expand this one. It will become xy plus 2y equal to 3 minus x. I collect those x, right, on the left side. So I want to bring that negative x to the left side. So I have xy plus with x. So I bring 2y to the right side, minus 2y. So I factorize x, so I have y plus with 1. This is actually 3 minus 2y. So I have x, which is equal to 3 minus 2y divided with y plus 1. You know that x is actually equal to h inverse of y. But you want to have the h inverse of x. So you just need to change the variable y with x. So you have a h inverse of x. This is actually 3 minus 2x divided by x plus 1. Right, so we are done with this inverse function. Right, now we need to see the domain and range of the inverse function. So we should know that if we have the object as x and the image is fx, so that is the function that maps to it is actually f, and the other way should be f inverse. So we know that, right, if this is actually the domain of f, right, and so this should be the range of f. Now if we consider the f inverse here, so this part will be the domain of f inverse, and this part will become the image of the F inverse, right? Now let me highlight this. I hope you can see clearly. Now if we consider this F inverse, all right, so we will have, this is the domain of the F inverse, and this is the range of the F inverse, right? So we can conclude that if we have the domain of F, this is actually equal to the range of F inverse, and we will have range of F, this is actually the domain of F inverse. All right, now let's try to see the relation between these. Suppose we have this function. We have to find the F inverse of x. Right, so we just let y equal to 2 plus square root of x plus 2. So I bring y minus 2 equal to square root of x plus 2. I want to make x as the subject. So I have, right, x plus 2. This is actually equal to y minus 2 square. Now I divide with 2. So I have y minus 2 square divided with 2. That is the inverse function. But this is actually F inverse of y. I want to have F inverse of x. So what should I do? We just need to substitute, replace the variable y with x. So you have x minus 2 square divided with 2. So how to find the domain? Alright. So you should know that, alright, firstly, the domain of F inverse is actually the range of F. And the range of, what do we call? The range of F inverse is the domain of F. Right, now we can clearly see right here, right? If you want to see the domain of F inverse, you just consider this F inverse function, right? Let's just consider this function. Can you substitute with any values at the variable x? Of course you can, because there is no restriction here. You can substitute with 0, -4, -2, +4, +2, and any values. Therefore, in this case, the domain of F inverse will be any, what we call, any real number. So from -infinity until infinity. Alright, if you have the real number line, so it can be any real number. Alright, now what about the range of F inverse? The range of F inverse, sometimes you are not certain about this. What will happen to this? Alright, so you can see, if you don't believe, if you can't see clearly, so you can see the range of F inverse is actually the domain of F. So the domain of F, alright, so the domain of F is actually, alright, you see the initial function here, which is F. The domain of this function, you can substitute in any values except, alright, because in this, you know, in this square root should not be less than 0, right? So x plus 2 should be greater than equal to 0. It can be equal to 0, but it cannot be less than 0. So x should be greater than -2. So our domain of F is actually from -2 until infinity. Alright, so you try to substitute with -2 inside this, will become 0. If you try to substitute with a -1, will become 1. Try to substitute with what we call 0, will become square root 2, and so on. So you can be from -2 until infinity. So you got the domain of F inverse and the range of F inverse, right? Now let's try to see the pattern of this type of questions. Suppose we have this example 4. We need to find the, what we call, H inverse. So let's just let y equal to x equal 1 over x. Now I bring that y minus x to the left side. I expand, I have y minus xy equal to x. Now I want to bring those x to the right side, so x plus xy. I factorize x, I'll have x 1 plus y. Therefore, I have y divided by 1 plus y. This is actually equal to x. So we know that this x is actually the H inverse of y. So what if we want to write H inverse of x? So we have the variable y being changed to x. So x over 1 plus with x. Now, to find the domain of H inverse, you just look at this function H inverse. You can substitute with any values except, because this part cannot be 0, therefore you cannot substitute with -1 here. Therefore now we have the domain of H inverse is actually any number except -1. So negative infinity until -1 union with -1 until infinity. But to find the range of H inverse, this is actually the same as the domain of H. Look at the function H. What is the domain here? You can substitute with any values except 1, because if you substitute with 1, it will become 0 at the denominator. So it is undefined. Therefore, you will have a negative infinity until 1 union with 1 until infinity. Right? So you are done with this one. Okay, now let's look at this example 5 here. We are given with two functions. We need to find the f inverse, right? So this is f, right? So we'll just let y equal to square root of 3x minus 1. So y square is equal to 3x minus 1. Therefore, I'll have y square plus 1. This is equal to 3x. Therefore, x is actually equal to y square plus 1 divided with 3. So this is actually the f inverse of y. You want to find the f inverse of x, therefore you just need to substitute the variable y with x. So you have x squared plus 1 divided with 3. Secondly, this is part A. For second question, B. We need to find the domain of G. Look at this function. So you can substitute with any values except you cannot have, right? Recall that you cannot have x squared minus 9 which is equal to 0. Cannot have. Therefore, x squared should not be equal to 9. Therefore, x squared should not be equal to plus minus square root of 9, which is the plus minus square 3, right? You cannot have x as the plus minus 3. Therefore, the domain for G in this case is actually from negative infinity until negative 3 union with from negative 3 until 3 union with from 3 until infinity. That is the domain of this function G. What about the range of f inverse? So to find the range of f inverse, we recall that, alright, range of f inverse, this is actually the same as the domain of f, right? So look at this function. What is the domain of this function? Domain of f, right? We know that we cannot have the 3x minus 1. It should be greater than equal to 0. We cannot have a negative number inside the square root. So what will happen? We have to simplify this one. X should be greater than equal to 1 over 3. So the domain of f is actually, it can be 1 over 3 and it can be bigger than 1 over 3. So from 1 over 3 until infinity. Right, so we are done with the second question. Now let's go to question C. What if we have this equal to this? Alright, now we have the G composed with fx. We don't have, so we have to find G composed with fx, meaning to say that this is question C. We have to find the G composed with fx. So fx is actually square root of 3x minus 1. So this is actually 1 over square root of 3x minus 1 square minus 9. Simplifying this, we get 3x minus 1 minus 9. Therefore, I'll have 1 over 3x minus 10, right? So that is the composite function. It says that, right, we should start with this condition. We are given with this condition, then you start with that condition. So G composed with fx is actually equal to f inverse of 1. So this is actually 1 over 3x minus 10. This is actually f inverse of 1. You just need to substitute 1 at the variable x. So you have 1 square plus 1 over 3. So simplifying this, we'll get 3x minus 10 here. This one is actually 2 over 3. So you will have, right, 3 which is equal to 6x minus 20. Therefore, I have 6x which is equal to, you bring negative 20 to the left side, therefore it becomes positive. Therefore, you have 23. Therefore, x will become 23 over 6. You are done with this one. Alright, now let's look at the final example here, last example in this video. Suppose we have two functions here. we are asked to find the g composed with fx, right? G composed with fx. So firstly, we have g f of x, that is g composed with fx. So g fx is actually x squared minus 32. So we have the 4 x squared minus 32 plus with 122 divided by x squared minus 32 minus 4. Simplifying this one, we will have 4x squared minus, that one is actually 32 with 4 will become minus 128 plus 122 divided by x squared minus 36. Therefore, we will have 4x squared minus 6 over x squared minus 36. What about the domain? Right, we know that the domain in this case, the domain of g composed with f, right, we can have any real number except at -6 and 6. So we have a negative infinity until -6 union with -6 until 6 union with 6 until infinity. Now I guess we tried this one, right? Now we want to focus on g inverse, right? I want to show the g inverse. So what if we have g inverse? So we want to write y equal to 4x plus 122 divided by x minus 4. I want to make x as the subject, right? So y x minus 4, this will become 4x plus 122. Simplifying this, I'll have xy minus 4y will become 4x plus 122. I bring those terms with x on the left side, therefore I have xy minus 4x. This is actually equal to 122 plus 4y. Simplifying this, factorizing this, we'll have y minus 4 will become 122 plus 4y. Therefore, I'll have x, which is given by 122 plus with 4y divided by y minus 4. That is actually the g inverse of y. Therefore, if I want to write the g inverse of x, I will have this as 122 plus with 4x divided by x minus 4. What about the domain? Alright, you look at this composite, the inverse function. Its domain is actually given by, alright, you can have any real number except at 4. Alright, you cannot substitute with 4 because if you substitute with 4, it becomes 0 at the denominator and then it will be undefined. So it can be from negative infinity until 4, union with 4 until infinity. So that's the domain of this inverse function. So that's basically the inverse function. So I hope you enjoyed this video. Thank you for watching.